So we are beginning a new topic today, and this is called oscillatory motion. In particular, we will talk about simple harmonic motion. But to talk about oscillatory motion is described as a repetitive motion around a central point. So let's say if we have some particle which is moving in the positive x direction, say up and down. Let's say it goes faster in this direction. This is the central point. CP is, let's say, the central point. It goes faster in this direction, but and then comes back to the central point, and then goes a little slower onto the other side, and then again comes back to central point. So if we plot this motion, then this will look something like this. So this is oscillatory motion this particle is trying to do. There is a special class of oscillatory motion, and that is called simple harmonic motion. And this is an important motion, or this is at least an important concept, because this is backbone of many theories in physics. And also in our day-to-day life we see many systems performing simple harmonic motion. But how do we really categorize simple harmonic motion? A simple harmonic motion, when oscillates about a central point, so let's say the central point is on the x-axis when x equals 0, and this is the central point. And when the simple harmonic motion oscillates, a simple harmonic motion for this particular system looks like this. And this is a sine wave. So it will make more sense. This is a little incomplete, but this is how a simple harmonic motion looks like. The trajectory or the path it follows is given as sine omega t, and we'll understand what does this mean. Okay, but there is one thing, which is that it may happen that so what we can see from here, we see that if t equals 0, then x is also 0, because sine 0 is 0, same as here. And when t equals in fact 2 pi divided by omega, x is 0 again. So this is t equals 0, and this is t equals 2 pi divided by omega, because for this is what we get here. We get x equals sine 0, and here we get x equals sine 2 pi, right? And both of them are 0. So this is the first point and this is the second point. So let's talk about different variables here which are playing a role. First of all, we see this is one complete cycle. So we went from 0 here. So omega t, let's also write omega t. Omega t is 0 here, and here omega t is 2 pi. So we started at 0, and the complete cycle, after one complete cycle, omega t is 2 pi, which means we covered one cycle, one circle. And the time it took to complete this one circle is 2 pi over omega, because we started at 0 and we ended at 2 pi over omega. So we are saying that time to complete one cycle is 2 pi divided by omega, and this is expressed or represented as a capital T, and is also called the time period. time taken to complete one cycle. And there are some related definitions like frequency. Frequency is defined as number of cycles every second. So if time taken to complete one cycle is capital T, you can sort of figure out that frequency should be 1 over capital T. Okay, there's one more thing, which is omega we haven't talked about. What is omega? Well, omega is the angular frequency. So if it takes time t to complete, so it takes time t to complete one cycle, then you know that each cycle has 2 pi degrees. So if you make one cycle, it has 2 pi radians. 2 pi radians. So angular frequency, angle traveled over time is 2 pi divided by capital T. So again, this is how we define angular frequency: amount of angle traveled divided by the time taken. Same as velocity, amount of distance traveled or displacement traveled divided by the time taken. So looking at these formulas, you can write omega equals 2 pi over t. So this is angular frequency. And all these three definitions, time, period, frequency, and omega, are actually telling the same thing, just giving one information. Okay. So, this was regarding some variables. Let's talk about few more variables, which is, here we have mentioned x equals sine omega t, which means the maximum, what is the maximum value of sine omega t? The maximum value of any sine cannot be more than 1. So the amplitude, which means the maximum value x can achieve, is just 1. So x equals a sine omega t means a is the amplitude, which means instead of going up to a maximum value of 1, graph is now going to a maximum value of a, capital A. So this is called amplitude, and we'll talk about more variables in the next lecture.